plane flies 500 miles per hour in the direction south 35 degrees east. A gust of wind blows from the northeast at 50 miles per hour. What is the magnitude of the resultant force? I think we should start by trying to sort of draw this out. So that'll be north, south, west, east. And we've got our plane. So what it means by south 35 degrees east is we're going to start going south, but then just move 35 degrees toward the east. So this vector right here with a length of 500 and an angle of 35 degrees in there is our plane vector. I'll call it vector P. Let's do our wind. The wind blows from the northeast. So here's the northeast, but it's blowing from the northeast, which means it's blowing toward the southwest. Just a little bit, though, compared to the 500 at 50 miles per hour. By the way, that would be at a nice, perfect 45-degree angle, wouldn't it? So we've got a 45-degree angle in there because it's blowing straight to the southwest. All right, so basically we just want to make a vector for each of those quantities. So we've got our plane vector, I just need an x and a y for that. So let me see. So I've got an x and a y, I might use this angle up in here. What would that be? 80, no, 90, so is that 55 degrees? If this is 35, then that's 55. That seems right. So then my x value, I could use cosine to find that. Cosine of 55 equals x over the hypotenuse is 500. Sine of 55 would help me find the y value over the hypotenuse. And so then if we just solve both of those, grab a calculator, 500 cosine 55 and 500 sine of 55. All right, so I've got 286.788 and 409.576 going on here. Should either of those be negative? And I'm going to say, since it's going south, I'm going to make the y value negative. East should be positive, so I'm happy with that. Well, let's do the wind. So my wind vector is blowing straight this way. If you wanted to enlarge it, you could. So the hypotenuse is 50, and so if we wanted to find our x and our y for that, we'd be all x, y, and that's a 45-degree angle. So you can either do your 45, 45, 90, or you can stick with sines and cosines. Either way will work. Our hypotenuse is the 50 miles per hour. So, you know, just to save time, do you want to do 50 divided by the square root of 2? I'll even put that as a decimal for us. So each of these sides will turn out to be the same length, and my calculator says 35.355. 35.355. Again, we could have set up another one of these. Cosine of 45 equals x over 50. Should either of those be negative? Since we're still going south, and this time we're going to the west, and west is left, which would be represented by a negative. Lovely. So step 1, find the vectors to go with. Why can't I erase? Troubles. So many troubles. Okay, I give up. All right, so once we have those two vectors, to find the result of those two vectors, we will add them together. What happens when the wind hits the plane? So plane plus wind equals, and we're just going to add the x plus the x and the y plus the y's, component-wise they call it. So that 286 number plus a negative 35 number. And I'm getting positive 251.433. And then I've got the negative 409 plus the negative 35 for a total of negative 444.931. That is the resultant vector. And what that tells me is that our plane is still going positive, so to the east and to the south. So it's still going somewhere towards the southeast, but at a different angle, right? Let's try to draw the parallelogram just so we can visualize. So our resultant vector, this one that we just found, is the vector that's going right there. So you can see that the plane got blown a little off course. And it actually looks longer, doesn't it? Doesn't it look like it got sped up by that wind? And so that's what we're going to find out, what the magnitude of that resultant force is. That represents the speed after the wind affects that plane. So how do we find the magnitude of that resultant force? We're just going to do the old square root. So we're going to take that 251 number. I'll do it more exact when I type it in. And the negative 444 number, and type that in. Just a moment. And that's coming out to 511.060. And I was right, it did get sped up a little bit, right? It started out going 500 miles per hour. Now it's going a little faster. Now, if you wanted to, you could also find the direction that it's going. And usually what we like to do for direction is use a tangent. And the reason we like to use a tangent is because we know that tangent of theta is the y value over the x value. And so if you just take an inverse tangent of the y over the x, that's going to give you a clue to how far it got blown off course. This is probably no longer a 55-degree angle. It's probably a little more than 55. Let's see what I get. Inverse tangent of negative 444 divided by 251. Oh, sure. All right, so when I do my inverse tangent, I get negative 60.529 degrees, where previously, remember, it was 55 degrees. So it actually got blown off course by about 5 degrees. And so then we could, translate into what a pilot would understand, whether you measured this vector from the north going around this way like pilots usually do, or whether we just said south, something a little bit smaller east, however big that would be. 90 minus 60.529, so it'd be south 29.471 degrees east, so not quite as far east as it used to go since the wind came. I hope that helps a little bit.